Sanibonani, igama ngundiko, and I'm your mathematics and physical sciences tutor. Okay, welcome back to the channel. If you are new to the channel, please do subscribe to the channel and like this video. If you are part of the family, thank you for coming back. Without further ado, let's get started. So in today's lesson, I want us to really focus on the homologous series Yama haloalkanes as well as alcohols, right? So with Yama haloalkanes, in other words, your alkyl halides, right? So we are told that they are chemical compounds consisting of alkanes with one or more halogens linked to them, right? So we know that with a normal hydrocarbon, right, which is your alkanes, right? You usually have, okay, let me just use a red pen. You usually have this carbon atom bonding with hydrogen atoms. And because our carbon atom has four covalent bonds, it has to have four bonds with the hydrogen atom. All right. Now, it differs when it comes to amahaloalkanes. Amahaloalkanes are hydrocarbons with halogens. Halogens in this particular case are these ones over here. We have chlorine, we have bromine, we have fluorine, as well as iodine. All right. So I'm just going to designate an X as part of these halogens over here, right? So we will have our normal carbon atom with four bonds or four covalent bonds, right? Each bonding with our H, and this last part is designated for that X, which is part of your halogens, right? And remember, our halogens, they only have one bonding site, or they may bond only once, right? If you remember on our introduction video, if you haven't checked it out, please do go back and check it. Yeah. So I'm just going to make maybe like 4 examples with each of these, right? So the first example would be having our chlorine with ethane, right? Ethane, remember, is the second uh, carbon, right? Or the second, what's it called? Hydrocarbon. Yeah. Okay. So the first one, it has 2, right? Because it's an ethane and haloalkanes are alkanes, so there is only one bond between their carbon atoms, right? And we have to have 4 covalent bonds. So in this particular case, because there's only 2, it doesn't matter um, on which carbon atom you add this chlorine, right? Atom over here. Um, you may designate this as 1, 2, or 1, 2, still the same, right? So I'm just going to write it here on the side, right? And then we're going to have our hydrogen atoms bonding with this. Now, this now is a haloalkanes, right? Now, I'm not going to start naming these compounds yet because we have not dealt with naming of organic compounds, right? But if you already know what this might be named, please comment down below the IUPAC naming of this molecule or any other molecule we might be drawing, right? Okay, moving to the second one, we're going to have our bromine within the hydrocarbon, propane, right? The alkane propane. Okay, so I hope you'll be able to see that. I'm just going to draw 3 carbon atoms, right? Propene is the third atom. It has 3 carbon atoms, right? It's an alkane, so there's single bonds over here. So we're just going to write these covalent bonds, all right? So in this particular case, do not stress yourself much about where to place this bromine, right? We'll get to that section as we go along, where we deal with Markovnikov's rule about the major product, the minor product, right? But in this particular case, I'm just going to use the terminal carbon atom, right, on either side so that it can be simpler for us. Okay, so I'm just going to write our hydrogen atoms, all right? And then there by the terminal, right, I'm going to write our bromine. Okay. Now, on to the fourth one, which is a fluorine and a pentane. Pentane, remember, is the fifth, right? We have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, right? So a pentane is the fifth. So it has 5 carbon atoms, right? And it's an alkane, so there's single bonds everywhere, right? So I'm just going to write our covalent bonds similar to the other ones. I'm just going to designate it and write this halogen in the terminal. All right. to avoid confusion. Okay, right, so we have our fluorine over here, and then lastly we have our iodine with heptane, right? Iodine with heptane. Heptane is the seventh, right? So it has 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7, right? Okay, just gonna write our covalent bonds, right? Similar to this one and this one and this one. I'm just gonna write it in the terminal. Always remember, you write these in capital letters followed by small letters, right? So our hydrogen atoms. Ish, I know this sometimes gets tiring, but please, 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 please do not forget to do this in your examination or you will be penalized. Okay, now that we are done with this, let's get to the nitty-gritties, all right? And the more dirty work now. Okay, so as we did in the previous lesson, right? We structured our halo hydrocarbons rather, which were our alkanes, alkenes, and alkynes, right? In this way, where we wrote down their general formula, functional group, their suffix, examples, structural formula, condensed structural formula, as well as molecular formula. Okay, so I want us to start with an example before we get to each of these halogens over here, right? So with E general formula of haloalkanes, remember the general formula yama alkanes. We have CN H2N plus 2, right? Now, in this case, it's like we are substituting one H for the halogen, right? So if we're going to minus 1, we're no longer going to be adding 2 at the end. We're going to be adding just 1 and that halogen, right? So our formula in this case would be CnH2n plus 1 and that halogen, right? So I designated it with UX, but we all know that UX is equal to chlorine or bromine or iodine or fluorine, right? Please, please, please do not forget that. Do not forget that. Use that logic, your mathematical logic, so that you get yourself back on track, right? Okay. Now, with E functional group haloalkanes, the functional group haloalkanes are within the word itself, haloalkanes, or in other words, alkyl halides, right? So we don't have to beat around the bush about that. So I'm just going to draw their functional group as we go along. So like I did in the previous example, we have this carbon atom with 4 covalent bonds, right? But on the side is this X over here, which may stand for your chlorine, your bromine, iodine, and fluorine, right? Please do not forget that. And these other covalent bonds or other bonding sites are for your hydrogen uh, atoms, right? And a suffix here too, because these are alkanes, the suffix is ane, right? Ane. Pretty much and very similar to our alkanes, right? Remember, these are hydrocarbons. We are just adding halogens, right? And their functional group are haloalkanes. So something to think about, just look at this portion over here in the name alkanes, haloalkanes, right? Halogens plus alkanes. Okay, so an example that we might be given, let's see. Okay, let's take 2 bromo. Okay, the space is 2 bromo propane. Okay, I hope you can see that this is 2 bromo propane. 2 bromo propane. Remember what I said about the naming of these, right? Echlorine, it's chloro. Bromine is bromo. Iodine is iodo. Fluorine is fluoro, right? Okay, now structural formula here, 2 bromo propane. So let me just write our propane. Propane has 3 carbon atoms, right? So I'm just gonna write these covalent bonds over here, and we are told that this bromo is in the second carbon atom, right? Whether up or down, you choose. So I'm just going to pick up, right, so that it is visible and you can see clearly. and I'm just gonna write level H to complete this structural formula over here. Okay, right? Remember 1, 2, 3. Even if you started from this side, 1, 2, 3, still the same, right? Okay, now with a condensed structural formula. Okay, remember what I said in the first episode. And when you're doing a condensed structural formula, don't try to complicate things. Just look at your structure. Whichever side you start off from, you start counting from there, right? So me now, I'm just going to start from the left towards my right. And so in the left, the first carbon atom, we have one carbon atom, okay? And we have 1, 2, 3 hydrogen atoms. Okay, now, in the second carbon atom, let me write that down. In the second carbon atom, we have one H, okay, interesting, as well as a bromine. Ooh, yes, okay. Now, in the third and last carbon atom, we have one carbon atom and 1, 2, 3 hydrogen atoms. Can we agree? Hmm, okay. Now, moving on to our molecular formula. Molecular formula, remember what I said? Don't complicate all of this thing. Just count your atoms, or the organic compounds you're given, right? So in this particular case, we're going to start with our carbon atoms. How many carbon atoms do we have? We have 1, 2, 3. Okay, so we have 3 carbon atoms. How many hydrogen atoms do we have? We have 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 hydrogen atoms, and lastly we have 1 bromine. Now, if we can relate this to our equation, which is our general formula over here. Remember this equation, we have CnH2n plus 1 and that halogen, right? So in this particular case, we have C, and this 3 represents our N, right? And for the H, we have 2 multiplied by N. So if we multiply 2 with this 3, it's going to give us 6, right? Remember, in this general formula, we are adding 1. So adding 1 here, it's going to be a 7. Okay. Makes sense, right? Now, let's move on to the second example. We have echlorine. Okay, with echlorine, our general formula in this particular case, we're going to have CnH2n plus 1 and UCl, right? Now, if I use, let's see, ethane, right? So we're going to have 2 carbon atoms, right? And you can decide where you want to write this. You can choose the first one or the second one. It's up to you. So me, I'm just going to choose the second one, right, for our functional group. And then our suffix is still the same as ane, because it is an alkane bonding with a halogen. Haloalkane, alkane. Okay, so with the example name, okay, so it's just going to be 1 bromo ethane, right? So 1 bromo ethane. I hope you can see that properly. And for some of you, you might be thinking, no, man, because it's on the first one, we don't have to write this 1 bromo ethane, but you actually do, eh? Please consult with your teacher. If you have any other questions, please do comment down below and let's debate about this. Okay. Okay. So structural formula corner, because we have, man, we already wrote this, so this kind of doesn't make sense, but yeah, let's just do it for practice sake, right? Don't be like me, right? Okay. Okay, structural formula, I guess we just had to add level H, right? Okay, now with the condensed structural formula, remember what I said. If we may designate, let's say this is 1 and this is our second carbon atom, right? So looking at this first carbon atom, right, we have 1 carbon atom and 2 hydrogen atoms, right, as well as 1 chlorine. Okay, and in the second carbon atom, we have 1 carbon atom and our H by 3, which is our hydrogen atoms. Okay, does this make sense? I think it does. Okay. Now with molecular formula, remember we're just adding everything. So we have 2 carbon atoms, right? And we have our H, which is our hydrogen atoms, is the 1, 2, 3, 4, 5. Okay, 5, and then lastly our Cl. Remember with our formula, right? If we designate this n as 2, so 2 multiplied by ON, which is going to be 4. Remember, we are adding 1, it's going to be 5, as well as our chlorine. I think we're getting the hang of this, right? So, just going to do another example, and I hope you're getting the hang of this, right? Okay, so Because we did ibromine, let's try iodine. Okay, very interesting, very interesting. Okay, so with iodine, the general formula in this case is still the same, CnH2n plus 1, and our I. Remember, the I is in capital letters, always, always. Don't make a mistake of not writing that in capital letters. So I'm just going to choose, let's see, butane, right? So, okay, in this particular case, let me just, not spoil it as such. For our functional group, we know that it is always like that, right? And then a suffix is still the same, which is ane. And then our example, we said e-butane, right? And let's see, where can we place our halogen? In the first or the second? It can't be the third because when you count from either side, it's still going to be the second, right? So let's choose 2 iodo, right? Iodo butane. Naming these is a bit weird, I know, but yeah, very interesting. So with butane, we have 4 carbon atoms, right? I'm just going to try and write these as small as I can. Remember, this is an alkane, right? So we have single bonds, and we have to make these 4 covalent bonds each, right? Because our iodine is attached to the second carbon, if we designate this portion from the left towards the right as our naming system, 1, 2, 3, 4, right? So our iodine is attached to this carbon atom. Up or down, you choose. I love using up, right? Okay, now we just have to complete the structure. Remember, you have to write our H barcode unless you want to lose marks in your examination. And since you are here, I guess you do not want to lose your marks. Okay. Now, we are done with that. We're just going to do our condensed structural formula, right? So, with a condensed structural formula, Anna, we just look at each carbon atom as we go along, right? So, in the first carbon atom, we have 1 carbon atom and 3 hydrogen atoms, right? In the first one. In the second one, we have 1 carbon atom, 1 hydrogen atom, as well as 1 iodine or halogen, right? So we just have CHI, right? No numbers whatsoever. In the third carbon atom, we have 1 carbon atom and 2 hydrogen atoms, right? And in the last, which is the fourth one, we have 1 carbon atom and 3 other, sorry about that, 3 other hydrogen atoms, right? And with the molecular formula, we are just adding everything that we see. We have 1, 2, 3, 4 carbon atoms, so we have 4 carbon atoms. And if we may use this formula over here, right, for our H, we are supposed to multiply this by 2 and add 1, right? So 4 times 2 is 8 plus 1 is going to be 9, okay? And lastly, we have our iodine. Now let's confirm. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I think we got this. Okay. Now, okay. Now, before we move along to our second homologous series, which is alcohol, please make sure that you liked this video, you're subscribed to the channel, you've hit the notification bell so that you can be notified every time we drop or upload a video, right? Your support is much appreciated. Okay, now let's get started. Okay, now with alcohol, very interesting portion, right? So with alcohols, we have 3 different types of alcohols, but before we go there, let's just start off with the definition and getting to understand what are alcohols, right? So the an alcohol is an organic compound that has an hydroxyl group, which is the OH, bound to a saturated carbon atom. Saturated, they mean an atom or a hydrocarbon that has single bonds only, right? So yeah, single bonds only, no double bonds or triple bonds, right? So in an example, we would have our carbon atom having 4 covalent bonds, right? So, and our OH, this hydroxyl group, is going to attach to that portion over there. Now, this is a debate. There are some people who love using just the O and then another line or a dash and then an H, right? But in this particular case, I'm just going to use O H, and I'm gonna separate these as we go along. but I just want you to, take note of that, right? Now, we can, okay, I did this so that we can have an area of examples, right? You can write it like this, you can write it like this, right? You can also write it over here like this. It is up to you which way you want to do it, right? But it's always the O first and lastly the H, right? And remember, the O is always bonded to two bonds or other atoms. Remember in our introduction video, and then our H only bonds once or with one other atom, so it is bonding to this O, right? And this O, it is bonded to this carbon atom as well as this hydrogen atom. Yeah, just to make sense of it. Okay, now remember when I said alcohols have three types of alcohols, right? We have a primary alcohol, secondary alcohol, and tertiary alcohol, right? So with the primary alcohol, it is an alcohol in which the hydroxyl group, which is the OH, is bounded, right? Or attached to one single carbon atom or terminal carbon. Okay, so if we have a situation like, let's say we have three carbon atoms, right? We have a propane. Okay, so to make sense out of this, but it is attached to one single carbon atom or a terminal carbon. A terminal carbon in this particular case is a carbon in the end, which is either the first one or the second one, right? Okay, so you can choose whether you attach it over here or here. I'm just going to choose here, right? So I'm going to follow this logic, right? And remember, you have to complete your structural formula and write those H's, because if you do not write them, you will forfeit your marks, all of them. They will not even give you a half a mark. Oh, crazy. But yeah, so with the secondary alcohol, right? Secondary alcohol, we get to learn that it is an alcohol in which the hydroxyl group, which is this OH, is attached to a carbon atom that is bonded to two other carbon atoms. Ooh, okay. Let's make sense out of this. But the OH group is attached to a carbon atom that is bonded to two other carbon atoms. Okay, now let's write three carbon atoms over here, right? Um, okay, let us complete the structure so that we have somewhat of a mental image. Okay, now what do they mean by two other carbon atoms? It means that this OH group is attached to this second, right, carbon atom. Let's say 1, 2, 3, this second carbon atom, right, because it is attached to 1 and 2 other carbon atoms, right, on the sides. Now we will have our H, our H, our H, our H, 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 and lastly we're going to have our OH. Remember, you can write this as OH or O-H, right? Now the last and final part of alcohols, we have tertiary alcohols, right? So we learned that it is an alcohol in which the hydroxyl group, which is this OH, is attached to a carbon atom bonded to three other carbon atoms. Becomes interesting now. Three, what do they mean? Okay, mind out. Come here. So we're going to draw our carbon atoms over here, right? Now, to make this, okay, let me complete the structure like this so that I can further explain this to you. Now, remember, with this one, it is bonded to two other carbon atoms, right? And this one is bonded to one carbon atom, which is this one, carbon atom. And with this one, for this one to bond to three other carbon atoms, it means that it would have to have 1, 2, 3 carbon atoms, or 1, 2, 3 carbon atoms, right? So I'm just going to write it up here, right? So now it kind of makes sense. It kind of makes sense if we use this horizontal chain over here by counting, right? So our OH group would therefore be over here. I hope you can see that properly. Okay, right? It is attached to this carbon atom, is attached to 1, 2, 3 other, right, of its kind, other carbon atoms. Now to complete the structure, we have to figure our hydrogen atoms, right? Please take your time when you do these complex or more spherical structures so that you do not miss any hydrogen bonding site. All right. Now, We are done with these. Let's get to the good stuff. Okay, I'm ready. Are you ready? Now, back in this table again, right? We're gonna do the same thing as we did before. This is so that you can practice. The more familiar you are with these type of things, structures, when they ask you about certain things, it becomes easier for you to recall or have a mental image, right? For you to remember. Yeah. So with this, we have our homologous series, which is our alcohols, and we have our primary, secondary, tertiary alcohols, right? And we have a general formula, functional group, suffix, examples of a name, structural formula, condensed structural formula, as well as molecular formula. Okay, let's get started. So with an example, I'm just going to use sort of like an easier one so that we can be acquainted. Remember what I explained previously on your haloalkanes, right? With the general formula corner, because we are just adding the OH group, right? We are just going to take out one H and add this OH group, right? So because it's also an alkane, it's going to be UCN H 2N plus 1 and that OH group, right? So it's similar to your haloalkanes, right? So if you seem to have forgotten that, please remember that those two are pretty much similar. So we have UCN H2N plus 1 and our OH group. Okay, okay. I hope you got that, right? And then our functional group in this particular case, we have uh, this carbon atom, right? And it's 4 covalent bonds, but in this particular case, the OH is bonded on the side. You can write it as OOH as it is, or O hyphen H, right? And yeah, you can decide to write the H's, yeah. But remember, it becomes interesting. They used the word hydroxyl group, which is this OH. Now, that group is the name of this functional group, Yama alcohols, right? And in this particular case, the name of the functional group Yama alcohol is the hydroxyl group. I hope you're spelling something right, right? Hi, okay. But yeah, it's the hydroxyl group, right? And the suffix in this particular case, remember, it's an alcohol. It's already in the name. So your suffix is going to be OL, right? Alcohol, all, proper, null, butanol, right? I hope you got that. So if we may use an example of a name, let's think of propane. Yeah, propane. Propane is fine. And where can we bond it to? Propane has 3 carbon atoms. Let's bond it to the first one. We're gonna interchange as we use these other examples over here, right? So with propane, let's see. We're gonna bond it to the first one. So it's gonna be prop on, right? Now we're gonna follow it dash and that one to represent which e bonded to which carbon atom, right? Propan 1 all, not propanol. If you wrote it as propanol, you were supposed to write at least 1 dash propanol, not propanol. Okay? Okay. Now, let's write the structural formula corner. We have 3 uh, carbon atoms, right? Okay, I'm just gonna write these because it's okay. Let's say 1, 2, 3. Because we wrote this in the first one, we can decide to use this one or this one. I'm just gonna use the first one. In this particular case, we have our O and our H, right? And just to make this complete, okay, okay. Now we're done with this. Our condensed structural formula in this case. Now we will have. Remember what I said. Remember, Anne? Okay. We have to look at each of our carbon atoms and start counting from there, right? So this first carbon atom is the only one of its kind, and we have 1, 2 H's, right? And we have this OH group over here. We write it separately. They are not equal in this particular case, right? And in the second carbon atom, we have 1 of its kind and 2 of our hydrogen atoms, okay? And in the third carbon atom, we have 1 of its kind and 3 hydrogen atoms in this particular case. Now, in the last one, we can decide to use this formula by, trying to see if we can gauge this, let's see if we can. I just want you to think differently when it comes to the molecular formula, right? So we have C, and in this particular case, how many do we have? We have 1, 2, 3. So we have 3. Now we know that our N is 3. And we're supposed to times by 2 and add 1. For our H, let's do that. 3 multiplied by 2 is 6, plus 1 is 7. And we have our OH group. Let's confirm that, right? We have 1, 2, 3, 1, 2, 3, C, right? And our H is now, we have 1, 2, 3, 4, 5, 6, 7. Okay, we have 2 plus 2 is 4, plus 3 is 7, right? Remember, this OH comes at the end, right? And how many OHs do we have? We have 1, right? And 1 on the side. Okay, think we got this. Now, with another example, because the general formula is always the same, I'm not going to write it, as well as the hydroxyl group. Okay, maybe let me write it, the functional group for the secondary alcohols, right? The primary alcohols may be similar to this one, but we may use a different example, right? So in this particular case, let me write 3, right, common atoms, which is our propane. And yeah, just gonna bond it here, O and H, right? This is the same as this one, hydroxyl group, hydroxyl group, hydroxyl group, right? Suffix OL, and the name of this, it's gonna be 1-propanol, the same as this one. So yeah, maybe let me just write the name differently, 1-propanol, right? Okay. Now, with the structural formula, yeah, I feel like it's the same, man. Come on. Okay, so now the secondary alcohol. Okay, now remember, these are the same, nothing changes, right? It's just that, yeah, we are emphasizing this whole thing. Okay, with a secondary alcohol, the functional group always is like this one, but if we may try to, make it familiarize it with a secondary alcohol, right? Remember, secondary alcohol is bonded to 2 other carbon atoms, right? If we use this propanol as we did, right? Because we are focusing on this one, and it is bonded to 2 other carbon atoms, so it will be over here. And remember, the name of this functional group is the hydroxyl group. Alcohol, it's all about hydration, blah 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 blah, right? Okay, so what am I doing? Okay, let me just complete it because I already started. And then we have our suffix all. Now, to name this, remember you can start from either side. You can start from this side to count 3, right? Or from this side to your left, right? Either way, you're gonna find the same thing, right? So because this is E3 carbon atoms, we have E propane, right? So it's gonna be propan, right? It's in the second carbon, so it's gonna be 2, and our suffix all, propan 2 all, right? Now, structural formula is the same as this one, so I'm not gonna write it. Our condensed structural formula now. Remember, we focus on each carbon atom as we go along, right? So in the first one, we have 1 carbon atom and 1, 2, 3 hydrogen atoms. So 1 carbon atom and 3 hydrogen atoms. In the second carbon atom, we have 1 carbon atom and 1 hydrogen atom, right? As well as this OH group, which is your hydroxyl group. Okay. And then in the last one, we have 1 carbon atom and 1, 2, 3 hydrogen atoms. Okay, now if we use the same logic again that we did by using our general formula for our molecular formula, the C's that we have are 1, 2, 3. This is always to establish our baseline, which is our N. So this would be our N. So 3 times 2 would be 6, plus 1 is 7 for our hydrogen atoms, right? And lastly, our OH. Okay, it's the same as this one. Yeah. Now, our tertiary alcohols now becomes interesting. So in this particular case, I'm just going to use butanol, right? So we have CH2N plus 1 OH, always, right? And our suffix is OL. And in this particular case, okay, let me just do this, right? So the baseline has to look something like this, right? This would be our functional group. Remember, the name of this functional group is always hydroxyl. Okay, you got this. Kikutsembile. Right. So, because we are focusing on E-butane and it is bonded to the second carbon atom, which has a branch in the second carbon atom, right? I know we haven't delved into the naming of our compounds, but you usually start off with the branch, which is your uh, homologous series or functional group, right? So in this particular case, we have uh, what's it called? The hydrocarbon, this methane, because it's the only one, right? So if we say 1, 2, 3, right? So it is bonded in the second, right, carbon atom. So we're gonna have 2 methyl, right? 2 methyl, 1, 2 propane. Okay, I thought this was gonna be a butane. Okay, propane, right? 2, because this OH is bonded in the second carbon as well. 2 all. All right. So we have 2 methyl propane 2 all, right? Now, structural formula CH2 is going to be the same as that other one, right? Remember, this carbon atom is a branch, right? Is a branch. So always include our H barcode. Make them visible so that the examiner can actually see what you are doing, right? So our OH group in this particular case, I'm just going to write it here. Remember the logic of our tertiary alcohol, right? The logic behind this is the OH group is attached to a carbon atom that is attached to 3 other carbon atoms, which is 1, 2, 3 other carbons attached to this one. Okay, now with the condensed structural formula, right? Uh, Now it becomes a bit tricky with this one because this is where you figure your brackets, right? But yeah, let's not get carried away. We have 1, 2, 3, right? This one is a side chain. So in the first carbon atom, we have 1 carbon atom and 3 hydrogens, right? And in the second one, we have this carbon atom, right? And as a side chain, we open our brackets, right? For this carbon atom, which has 1, 2, 3 hydrogen atoms. So 1 carbon atoms and 3 hydrogen atoms, we close that bracket, and then we come back to this OH group, right? And we write it. And lastly, we come to this third carbon atom, right? It has 1 carbon atom and 3 hydrogen atoms. So H3. Okay. Now, in the molecular formula, you may decide to use this one as well, but because we have a bracket, let's try not to complicate things. We can further investigate after establishing, how many things we have over here. So with AMA-COH, we have 1, 2, 3, 4. We have 4 C's, right? And AMA-HOH, excluding this hydroxyl group, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9, right? And lastly, we have our OH group. I think you can see the light now. Remember what we do with the equation here. Because our 4 represents our n, and we must multiply this 4 by 2 and add 1 for this h over here. 4 times 2 is 8. 8 plus 1 is 9. Oh, okay. I knew you would get it. Okay. And that's it for me today. I hope you enjoyed this lesson. I know it was a bit longer than usual, I'm trying to give you everything you need before your examinations, right? And yeah, I would just need your support by liking this video so that other people can get notified and, be aware of such content. And yeah, please do not forget to subscribe. Don't forget to hit the bell notification so that you can be notified when we upload a new video, right? And if you're interested in our tutoring program, please send us an email at physicswithndiko@gmail.com, right? Or send us a Facebook message, Physical Sciences with Ndiko, or use the link in our bio for any of our other social media platforms. From me to you, Danko.